Thank you so much. Okay, so we have this related rates problem. Anytime they are dealing with a cone, you always are going to do kind of the same exact procedure. We are going to think about what a cross section of the cone looks like. Okay, so we have this cone-shaped funnel. Water is draining from the bottom of it at a rate of 0.03 cubic feet per second. If you notice a cubic something, that is a volume. So we know that the volume is leaving the cone. So that would be a negative. Okay, so that also gives us our units should be feet. Our time should be seconds. So that very first line tells us that we need to draw a cone. We need to draw or consider what the volume is doing. Now let's read the second piece. It says the height of the funnel is 2 feet and the radius of the top of the funnel is 1 feet. So what we know is if it was filled all the way to the tippy top, the radius would be 1 and the height would be 2. Now, let's think about the fact that we are losing water, we're losing volume. So at some particular time, we are at some generic R and H. You always get a similar triangle inside of a cone, okay? So you're going to set up the relationship of the full container. So that would be the radius is 1 over the height that is 2. And those should be the same units. Those are both feet. And then you use the generic R to H. And then just cross multiply. So 1H is equal to 2Rs. Okay, so that should be something that you get in the habit if they mention a cone that is filled with something. Okay, so that's the second sentence. The third sentence says, at what rate is the height? So that is dH dt. Just put a at what rate is the height changing? So that's a dH dt. When the height of the water is 1/2 foot. So when the height is 1/2 of a foot. Okay, so we have a rate given to us about volume. We are looking for a rate about height. So we need an equation that has volumes and heights in it. So V and H. Well, I know that the volume of a cone is 1/3 pi r squared H. I know almost an equation with volume and height only. But what's really cool is if I solve this for R, I know that R is always 1/2 the height. So I can take this R right here and replace it with 1/2 the height. So that's a common thing that happens here also. The similarity in the cone gives us a relationship between the rate and the radius and the height. And so if I want the equation to only say height, I can substitute in for the radius, or vice versa. If I need it to be the radius, I can substitute in for the height. So what I know now is that the volume is 1/3 pi times 1/2 H squared H, or that the volume, when I get it all said and done, it would be pi over 12 H cubed. Okay, so now let's think about what we have here. We have an equation with volume and height. We have a picture. We have our rates that we know and the rates that we want to find. We have the instant we're looking at is at when the height is 1/2. Okay, so now we are ready to do the fourth step of DREADS. Remember DREADS, I drew a picture, I found my rates, I found my equation. Those are always the first 3 things you always do. And then that moves us to differentiate. Now we're differentiating with respect to time. So if we have an H in the equation, we tack on a dH dt. If we have a volume in the equation, we tack on a dV dt. Okay. So the derivative of a V normally is 1, but we have to tack on a dV dt. So it's 1 dV dt. When we take a derivative of pi over 12 h cubed, normally it's pi over 12 times 3h squared, but we have to tack on a dH dt. Okay. We should be able to now, after differentiating, solve. Remember our dreads. Draw a picture. What are the rates? What's the equation? Differentiate. Now we're ready to solve. That last thing is an S there. Doesn't look like an S there. Okay, so how do we solve? They told us earlier that dV dt was negative 0.03. That is telling us there was a loss happening. That any negative rate means it's getting smaller somehow. Okay. And then we have pi over 12 times 3. Now, what is our h? Well, they said at the exact moment when our height was a half of a foot. So that's 1/2. And then the only thing, if you did it right, that should be missing was the thing we were looking for, dH dt. And the only variable you'll notice there is dH dt. Now let's clean that up a little bit. 3 goes into 12 4 times, so we can cross that out. 1/2 squared is 1/4, so the 4s are going to cancel, so that's pi over 16. And to get rid of that fraction, we just multiply both signs by 16 over pi. So that's going to be 16 over pi times negative 0.03 is dH dt. Now the height is in feet, time is in seconds, so this is going to be feet per second. Let's get an actual number here. They went to 2 decimal places, so I'm going to go 2 decimal places. 16 times negative 0.03 divided by 3.14 to 2 decimal places is negative 0.015 feet per second. Now, why is it negative? Well, the height of the water in the tank is decreasing. The height is getting smaller. That's what the negative feet per second refers to. So that is how we do a cone one. Cone ones are used a lot. So if you followed that, if you see a cone problem, just refer back to that cone problem when you're doing it for your homework, okay? They love doing the cone problem because, you know, you can look for the height, you can look for the volume, you can look for the, you know, so there's lots of stuff going on in a cone problem, okay? Any questions about that one? Okay, so now let's take a moment and let's look at our homework. This homework is time consuming. There are 21 problems. The answers are down here, okay? It's important that you understand how to set these up. They're difficult problems. If you just give me an answer, you're getting 0 points. You have to do the work and show it every single time. And every problem, you're going to use the DREADS model, okay? So we're going to do some of those, and then I want to take a moment to talk about the project. There are 13 of you, and there are 13 problems, okay? I am going to have you pick a problem at random. You have to do all 13 problems. The answers are shown, but you are going to pick one to depict on a poster. More of a virtual poster, like you're going to create like a poster in Notability or in, if you have some other tool to create a poster. The rubric is there. You are going to, if you recall, if we did last year, the posters for trig, similar idea. So that's basically what we're going to work on for probably a little bit into next week as well. Okay, so I would like to do a few of the problems that you see here with you. At this time, could we do just the first one? So we're just doing some of the homework together. So again, as you do these problems, remember you want to follow that DREADS pattern. Okay, so let's take a look. It said an airplane is flying towards a radar station at a constant height of 6 kilometers above the ground. So let's assume this is our radar station. There's the ground. Here's our plane. It's going that way toward the radar station. And it is at a constant height of 6 kilometers above the ground. Okay. It says if the distances, or the distance S between the airplane and the radar station is decreasing at a rate. So the distance between is decreasing at a rate of 400 kilometers per hour when S is 10. What is the horizontal speed of the plane? So let's connect the two. Let's put an S. That's the distance between the height and the plane. The exact distance would be like if you're on the plane, you took a string and you connected it to the radar station, that would be S. It says the distance between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour. I didn't write anything down about that. So that's the next thing I want to say, is that the SDT is decreasing, so make it negative, at a rate of 400 kilometers per hour. And S is going to be stuck at 10. Okay, so now I got a little picture. I pulled out the rates and the information from the problem. And then it says, what is the horizontal speed of the plane? So let's put a little X here for the horizontal distance so that we can find what distance the plane is actually traveling horizontally. So we need to find the XDT. Okay, so we've pulled out every piece that they've given us from the problem. And so we have we've done the drawing and the rates. The first part of DREADS has that E in there. What equation relates S and X? Does anybody know what equation we could use to relate S and X? Yes. Exactly. The Pythagorean theorem is going to be used commonly for these. I know that S squared will equal X squared plus 6 squared. Sorry, I wrote that kind of weird, but so X squared plus 36 equals S squared. I don't know why I switched it, but anyway. Okay. So now I know a relationship between those things. So let's talk about again what we did. We took the information from the problem to draw a picture and pull out all the rates and the values that they gave us. We gave variables on our picture to kind of match everything. And now we are ready to do the differentiation, okay? So DREADS, the D, R, and E kind of all will flow together kind of at once. You'll be drawing the picture. You'll be putting variables on your picture. You'll be then find an equation that matches so that you can do the next step, which is to differentiate. So now we're ready to differentiate this with respect to time. So with respect to time, this would be 2x the x dt. The derivative of a constant is 0. That's always great when they say they're going at a constant, you know, or that they're at a constant, whatever. And then s squared would be 2s ds dt. Okay, so guess what we got? We have something really, really nice. Okay, so think about what we know. We know s is 10, so that's what we know. Great. We know ds dt is negative 400, So we know that. What do we not know yet? We don't know what x is. That's the only one that's missing. But at the exact moment when this is 10, if I know two sides of a right triangle, how do I find the third? Pythagorean theorem, that's what we use from the start. So you know that x squared plus 6 squared has to equal 10 squared at that exact moment in time. So 36 from 100 is 64. And then the square root of that is 8. Okay, so we know that x is 8. So now we know x, so we can plop that in. We know s, and we know ds dt. So now you should be ready to solve for the thing we're looking for. Remember, we were looking for dx dt. Okay, so let's plop the values in. We get 2 times 8 times dx dt equals 2 times s, which was 10, times negative 400. So how could you get dx dt by itself? Divide off the 2 and the 8. So dx dt is 2 times 10 times negative 400 divided by 2 divided by 8. Well, 2 goes into 2 once, so those cancel out real great. 8 goes into negative 400 negative 50 times. And then negative 50 times 10 is negative 500. Now, these are word problems. I want units. X is kilometers. So dx dt, and the time was hours. So this was just be kilometers per hour. Now, why is it negative? Well, the reason it's negative is the distance between, the ground distance between the plane and the radar station is decreasing. So that x is decreasing. So you should expect a negative number when the thing that the rate that you're finding is getting smaller. Okay, so that is number one. Does anybody have any questions there? Yeah.
So couldn't you just plug in that s equals 10, and that's in the word problem, into the equation standard?
No, because that's not constant. You have to differentiate before you plug it in. If they say it's constant, so they told us that the height was a constant 6 kilometers. That's why I was allowed to put 6 in then. We are not allowed to put the variables in until, unless they're constant, till after we've differentiated. Okay, so you have to differentiate because that thing is changing. So you always have to ask yourself, is the distance between the plane and the radar station getting smaller? Yes. It's changing. It has a rate that goes with it. So you're not allowed to plug those things in till the end. So you have to differentiate those things first. So if they say the great word constant, you're allowed to plug it in right at the start. If they don't say the word constant, you have to wait. That's a good question. Okay, so that's number one. I'm just trying to find one that's, let's do number 5. Let's do number 5. Many of the ones up there are going to be using either similar triangles, or number 3 is like the cone one we had done in the notes. Okay, so let's do number 5 together. Okay. It says, air is escaping from a spherical balloon at a rate of 2 cubic centimeters per minute. Now, I don't usually go any further from that first sentence before pulling out some information from it. So draw a sphere. As you can see, it does not have to be anything fancy. Okay. Okay. Now, this 2 cubic centimeters per minute, it is leaving the balloon. So the balloon is getting smaller. It is a volume decrease. So that will be negative, and that is a dV dt. Okay. So I've pulled that out of that first equation. So what do I know? I know my units are centimeters, our time for length, and our time is in minutes. Okay, now let's read the second sentence. How fast is the surface area shrinking? So I'm going to put the SDT. That's my question mark. I'm just going to call S, big S, surface area, okay? And at the exact time when the radius is 1 centimeter. Okay, now they've been kind and they've given us some formulas. We know the volume is 4/3 pi r cubed. We know the surface area is 4 pi r squared. Okay, so we don't have an equation with volume and surface area. We don't have that relationship. And it's really too hard to get that relationship. So what I suggest doing is the following. We are going to, since they gave us this, we can differentiate the volume equation because dV dt pops up in that equation. So let's do that equation. So we get dV dt equals 4/3 pi times 3r squared dr dt. Now, why is that important? Well, if I know the rate of the change in our radius, this formula then has a radius in it. And so I can, do some clever maneuvering there. Okay. So let's use this equation to solve for dr dt, okay? Because I know that the volume is -2 and the radius is 1. So let's plop in what we know. So the volume is -2. The radius is 1. So what's going to happen? Well, the 3's cancel. Great. 1 is just 1. So the only thing left to get rid on both sides is a 4 pi. So that'd be -2 over 4 pi. And that's dr dt. Okay. Now let's make that a little prettier. Let's make that -1 over 2 pi. So that would be centimeters per minute. Okay. Now I found dr dt. That isn't what they wanted, but I know dr dt. They know that at that precise moment, the radius is changing at a rate of -1 over 2 pi centimeters every second. Now let's go back to the surface area because that's what we wanted. Let's do the exact same thing and differentiate that. Okay. That says centimeters per minute if you were, yeah. Okay, so now let's go to our surface area formula. We know ds dt equals 4 pi 2r times 2r dr dt. Well, we know all those things, right? We know r, 1. We know dr dt, -1 over 2 pi. We got it, okay? So ds dt is what we were looking for. That's 4 times pi times 2 times 1 times -1 over 2 pi. Well, 2 pi goes into 4 pi twice. 2 times 2 times 1 times -1, just multiply what's left, is -4 centimeters squared per minute. Now, why is it centimeters squared? Well, surface area is an area. Area is a squared units. If you think about the fact that we really multiplied a centimeter times a centimeter per second, or per minute, I'm sorry, gave us a centimeter squared per minute. But the units should match. So number 5, the answer is -4. Okay, so that one's there. Anybody have questions about that one? That one's weird. Often, it's not often that we have to differentiate 2 separate equations. Usually there's a way to blend them and we don't never have to do that. But this one is like, how else would you do it? Okay, so that's 5. Yeah, definitely. Okay. Now let's go back to the homework again. And I would like to do Let's do 17. Okay, 17 says, a thin circular metal disc changes size but not shape when heated. So I'm just going to do the circular part. You can tell that's a circle, don't you? So, and they mentioned something about the radius, okay? And it says the disk is being heated so that the radius is increasing at a rate of 0.03 millimeters per second. So dr dt is 0.03 millimeters per second. Now I know it's positive because it said that the radius was increasing. So that's where it tells you to use the positive. So all I've done is I've made a circular shape and I've gone from the second sentence where it says the radius is increasing. So that's a dr dt. Okay. Then the second or the last sentence says, how fast is the area? Now I don't go any further. So I'll just say dA dt. How fast is the area? That means that's what I'm looking for. When the radius is 200 millimeters. So I need an area of a circle that has the radius in it, pi r squared. So I need area is pi r squared. So I've done the dreads. I have a picture. I've pulled out any rates, what I'm looking for, what they gave me. I've pulled out any other relevant information, and I found an equation that relates those things. So now I'm ready to differentiate. Now I'm differentiating with respect to time. So if I take a derivative of any variable that isn't time, which they're all going to be nothing with time, you're going to tack on that dA dt, and in this case, in a dr dt. So this is going to be dA dt equals pi times 2r dr dt. Do we know dA dt? No, that's what we're looking for. But do we know everything else? Yes, we know the radius is 200. We know the dr dt is 0.03. Let's stick in what we know. So that's pi times 2 times 200 times 0.03. And you could even put the units if you want. That does tell us that our units are square millimeters per second. Well, let me tell you, I'm going to leave the pies just usually as a pi. It's a good idea. Just leave a pi. And so it's 2 times 200 times 0.03 is 12. So I'm just going to write that as 12 pies. If you multiply by 3.14, that's fine. But most of the time, just leave a pi in your answer. That's fine. So the area is changing by 12 pi square millimeters every second. So are you starting to see some of the patterns that are occurring here? A little? Okay, so what I want you to do for the rest of the period is I want you to be setting these up. Even if you just start the first 3 steps, dreads, DRE, draw the picture, find the rates, what's the equation? Draw the picture, find the rates, what's the equation? Just focus on, for today, just those steps of those first problems, okay?